Welcome to today's event, the first installment of a new series on worst case scenarios, where we'll be examining important global developments, possible outcomes, and popular misconceptions about those outcomes. Today's worst case scenario focuses on artificial intelligence with two very special guests, Professor Missy Cummings and Dr. Paul Scharre. Professor Missy Cummings is currently a professor at Duke University's Electrical and Computer Engineering Department and the director of the Humans and Autonomy Laboratory. She's a member of the Defense Science Board, a former naval officer, and a pilot. She's actually one of the U.S. Navy's first female fighter pilots. She's a badass and hilarious. Second, we have Paul Scharre. He's a senior fellow and director of the Technology and National Security Program at the Center for a New American Security. He's the award-winning author of Army of None, Autonomous Weapons and the Future of War. Like Professor Cummings, also has military experience, having been in the Army's 3rd Ranger Battalion, and he recently finished a PhD in War Studies from King's College London. Thank you both for taking the time to be with us today. And to kick off our conversation, I'd like each of you maybe to take a shot at the big question that in some ways this broader series is about. Like, what's the worst that can happen when it comes to AI, and how worried are you about it? Professor Cummings, why don't we start with you?
Thanks for having me. Now I have to have some kind of badassery language here to live up to the expectations. So I will tell you that the thing that worries me the most is not the fear that a lot of people have that AI is going to kill us all, that somehow we're either going to end up in Minority Report or Terminator movies, and that AI is going to make our lives hell going forward, or maybe get rid of us altogether. You know, if you work in this field like I do every day, you're like, oh, we are so far away from that. What I'm more worried about from a national security perspective is that I really believe that this country has lost its military edge in terms of innovative technology. I think when it comes to AI, I think all of that is happening in the commercial sphere. I think we've lost the bubble. I don't think we have the right people inside the government. I don't think defense industry has people that know what they're doing. On a daily basis, I am flummoxed is the nicest word I can think of. I hit my head against the wall many times over the PR releases that I see coming out about who's got what AI program and what capability. I mean, the latest one was the F-35 is leveraging some kind of artificial intelligence to make it even better, which is just outright laughable. And even if it did, it would be a disaster for what is already a really bad program. And so I think, you know,
You're really not pulling punches here at the beginning.
You
just you rained fire on the F-35 already.
Oh, I can listen. There's way more, and the problem is because we're so far behind now, and we keep, you know, the emperor has no clothes. We keep pushing superfluous, superficial agendas that don't really address core problems. And now we have a huge gap in, there are no fielded technologies that have any real AI in them in the military. I'm not even sure we have any, what I would consider respectable AI technologies in the pipeline. And I'm not sure other countries do either, because it is a worldwide pandemic, not just COVID, but the overuse of the word, the phrase AI, and the claims that people have AI. But if we don't get a handle on this in very short order, people will start pulling ahead of us, like already is happening in the commercial sphere.
Thanks very much, Paul.
This is always tough to follow, but I'm going to do my best here. Look, I mean, I think we've all seen the movies. We know how this ends. No, I'm just kidding. I'm kidding. Look, I think it's a real challenge when we talk about AI risk that we certainly have a lot of popular conceptions about AI risk, you know, about one day the machines are going to wake up and they're going to turn on us and enslave us all. So how do we think about this in a grounded and realistic way? I think the answer to the question depends upon two key factors, right? One is, are we talking about AI technology today, which, you know, as Missy talked about, has a lot of limitations, oftentimes doesn't work, certainly doesn't live up to a lot of the hype. It's doing exciting things, it's powerful, it can do some interesting things today, but it's probably often oversold. right? So what are we talking about today? Or we're talking about how the technology might possibly evolve down the road, maybe some qualitatively more advanced form of AI that's not what we see today. Those are very different answers potentially to that question. And the other one is, how far are you talking about in terms of you're willing to push the probability tail thinking about risk, and over what time horizon? I think when it comes to near-term systems, probably the most dangerous, the most scary things would be the intersection of AI in anything that might affect nuclear stability. There's just nothing that has the destructive potential of nuclear weapons. Obviously, we're in a much better place as a civilization, as humanity, than we were, decades ago during the Cold War. We've been able to reduce nuclear risk, but it hasn't gone away. And there have been a lot of scholars that have written on ways that you might see AI intersect or exacerbate nuclear risk. I'm really not as concerned about, nuclear powers putting machine learning directly into their nuclear command and control architectures. I think that's probably very unlikely. But could you imagine the technology used in ways for, say, indications and warning, for intelligence threat assessments that might, heighten fears of policymakers? Maybe we saw examples of things like this during the Cold War in different ways. I don't think that's a tomorrow risk, but over the next couple of decades, it could materialize. If you're talking about, qualitatively more advanced forms of AI, then it's, I think it's much harder to know, right? How the technology might evolve. And there's a huge, wide range of, predictions that people have about how the technology might evolve over the next, say, 50 to 100 years. I would say that the thing that I'm least concerned about is sort of AI becoming self-aware and human-like. I think if anything, we've seen that the technology is very inhuman. It thinks very different. We've been able to build systems that are intelligent, but in ways that are very different than humans. And in fact, a lot of the anthropomorphization of AI is, I think, very problematic and leads to risks in how we might employ systems. And the risks are more likely to come from things that maybe don't work in quite the right way, or that work in surprising and clever ways, but maybe are not in the way that we intended, that might surprise us. And those risks would be, potentially exacerbated in the military space. People are building things that are intended for harm. I will drop in the chat window an article that I think is fabulous. It's a great one to read, called The Surprising Creativity of Digital Evolution. It's a collection of anecdotes throughout the history of AI development about surprising and creative and clever systems, really designed generally in a lab context, but they might give a flavor for some of the ideas that I'm talking about how machines might develop or come up with clever and interesting ways to solve problems. Thanks.
All right, so both of you, I think push back in some ways against this notion that we need to worry about like the robots coming for us, at least in sort of a fundamental way. So let me ask a conceptual question and then sort of dive into the things that I know that you're both sort of more focused on, which is, why is this where the I mean, maybe not where the expert conversation is, obviously, but where the public discussion still is? I mean, is it really just that James Cameron's vision of the Terminator was so powerful that we can't get it out of our minds? Or, why is it that even though I think all of us and things that we write in sort of different ways for different audiences have, emphasized this sort of, this point in one way or another, but it's like a zombie, it won't go away.
Well, I think you have a great point about James Cameron, because I think if we all think about what were we talking about 10 years ago? 10 years ago was killer drones. Killer drones were everywhere. They're going to take us all out. The FBI is going to have them. We're going to use them against our own people. We're doing horrible things overseas with drones. And then Amazon made an announcement they were going to start making deliveries with drones, and then people were like, "Oh, well, okay, the drones can be beneficial to me," and maybe I was a little preemptive on jumping the gun. And so I think that often what the media puts out there can definitely push a discussion one way or the other. And it's way sexier and more fun and scary to talk about AI that's going to take over the world, as opposed to what I see every day, which is incompetent AI and more incompetent students and practitioners of AI who don't know what they're doing. And it's not at all sexy to talk about, and we don't want to talk about it in this country, the fact that we are not nearly as good in this area as we're pretending to be.
Paul?
Yeah, I think there's a couple reasons. I mean, look, science fiction. I think it's fair to say that, you get a lot of media hype surrounding AI developments. There's some AI, research project that comes out, it gets a little bit sensationalized. I think you certainly see that in the military space. And some of the military AI developments draw a lot of sensationalism. In some cases, to be fair, militaries themselves promoting a lot of the sensational hype. But I also think, to give people credit, there's other factors that are maybe more real that are at work. One is that, we have a tendency to anthropomorphize other objects, right? We anthropomorphize our pets, right? We probably ascribe a lot more, internal maybe thinking to them than might be there. People name their Roombas, right? So we have a natural human tendency to sort of project these mental models of personhood onto other objects. And that happens, with AI systems that causes problems, to be clear, but I think that's real. But I also think it's fair to say that if we talk about intelligence and people are envisioning, something akin to human intelligence, or at least on par with it in terms of its capability, which is not what we're building today. It's not what we are, right? But when you use that term, it's not wrong to realize that intelligence is powerful. Humans have conquered the globe without, claws or sharp teeth or fangs. We're not bigger or stronger than other animals. We're intelligent, right? We're altering the biosphere due to our industriousness. Maybe intelligence is maybe not, necessarily the right word there, but certainly industriousness. So I think it's fair to realize that intelligence is powerful. And if we start thinking in the long term about being able to build machines that might have, that kind of intelligence on par with humans, that's a serious thing, right? It's not where we are today, but that would be a serious risk.
So I want to pick up now on something that Missy mentioned in her opening remarks, which was the notion that the U.S. actually isn't very. I mean, you both mentioned this in different ways. The U.S. is maybe not that good at AI, and you could think about this in either their absolute and relative terms. They're sort of not that good in terms of the ability to integrate AI into specific systems, and the hilarious F-35 example you gave would be illustrative of that. But there's also relative, and how the U.S. is doing compared to potential adversaries, great power competitors, whatever like the term we want to use, like at the moment, like Russia and China. So, is there, in countries around the world are investing in AI because they believe, rightly or wrongly, that it could be a difference maker from a military perspective. How's the U.S. doing relative to its competitors? I mean, Missy, you sound nervous, but like, are you nervous, like a little bit nervous, or nervous like OMG nervous?
Well, let me wear two hats. I mean, one is my professor hat, where, I'm a professor of multinationalities of students. I have lots of collaborators around the world. It is a global pandemic that we have incompetent AI everywhere. And I am very, very concerned about, this is true everywhere in the world, probably even more in China than in America, is the fact that we field incompetent AI and we don't ask questions about whether or not we should be fielding it, or how it should be fielded, or whether or not it should be tested. So, and this then relates to the national security hat, which is people can put out technologies that are really, really bad, and are likely putting out technologies that are really, really bad. We just have to look over at the self-driving car world to find out that there's a space race, an equivalent space race going on in the commercial world of self-driving cars. And I've got news for everyone. You're not getting them. You're not getting them tomorrow. You're not getting them next year. Elon Musk is totally out to lunch. Love SpaceX. Autopilot, no. Full self-driving, no, not going to happen. If you want to see some scary, if you're driving a Tesla and you want to see some scary results, go to my website and look at the set of tests that we just did for human in the loop testing of autopilot, just to find out how really, when I say lame autopilot is, it's super lame in terms of keeping you safe. And the claims that they're making are not real. So, okay, you can get away with that in a commercial sphere, but what's the extension of that in the national security space? It means that I believe countries are going to start, and they already have, deploying elements of bad AI. So there is incompetent bad AI that may kill in areas and ways that we didn't anticipate. And for sure, that's going to happen going forward. And then there's the question of not deploying AI that we should be deploying. So I think there are a lot of places that we could be deploying AI. And as the director of the Humans on Autonomy Lab, of course, I'm going to say, I also think we're making a big opportunity, or missing a big opportunity, to combine the strengths of humans with the strengths of automation, machines, autonomy, to actually build more collaborative, powerful systems. But the research is clear that there's a huge opening of understanding that there's a partnership between humans and machines. And that's not sexy. That doesn't get a lot of the DoD funding. The National Science Foundation is not interested. Nobody's interested in looking at that intersection, which is actually where the true power lies.
Paul?
Well, this question of relative AI power is a great one. It's one that's certainly very much on the minds of folks in Washington and the national security community. I would draw a comparison maybe to the, some folks have said that AI will be like another industrial revolution. So if you kind of buy that paradigm, I would point out that the industrial revolution not only saw countries kind of rise and fall on the global stage, but also changed the key metrics of power. And so rather than just looking at population and size and GNP, you also had scholars of international relations looking at coal and steel production, energy consumption, manufactured goods. And if AI sort of achieves the kind of potential that people are talking about, then I think you're likely to similarly see some of those key metrics in power change with increased value in things like data, compute, AI talent. There have been two really good efforts that I've seen to try to rank countries, or in the case of the EU, supranational groups, on AI power, if you want to use that term. I'll drop both of them in the chat window here so people can check them out. But they kind of come to the same conclusion, which is that there's really two major standouts: the United States and China. The U.S. is ahead of China on most, but not all, indices today, but China is rapidly catching up and on track to overtake the United States in a number of these indices in the next decade or so. That's certainly the case when you look at things like research quality and other things. There's some differentiators depending on what we're talking about. Hardware is a key differentiator where there are some major choke points in global supply chains for chips, including in some unlikely countries like Taiwan and the Netherlands, for example. But I do think the trend lines, if you're someone who cares about democratic countries shaping the future of the world in the 21st century, the trend lines are very concerning because China is doing some pretty impressive things with AI technology. And the trend lines are ones where they're looking to overtake other nations.
So Missy, not to ask you to argue with Paul, but can you, you laid, you both made really good points, but in slightly different ways. And the tension between them might be that, Paul's description of maybe some of China's advances as impressive. And then Missy's like, look at this autopilot video on my website. Like, it's embarrassing. To what extent is, like, when we, Missy, from your perspective, when we think about what are the impressive advances in AI that are going on, now? And, how would you respond maybe to somebody that said, really, like, this stuff hasn't changed all that much since the 90s, since the problems of making decisions under, using computers to make decisions under uncertainty are just, like, too hard to solve, essentially?
Well, I could give a lecture for the entire rest of the day to go into the details about this. There are different flavors of AI. Not all AI is alike. Generally you can categorize the AI into symbolic AI and connectionist AI. And symbolic AI is kind of old-fashioned AI, operates by rules, some of the decision-making that you were talking about. And that really has not changed a lot over the years. Where the big leaps have been made lately have been in connectionist AI, using neural nets to potentially represent some kind of reasoning, although we could argue later about whether that's really reasoning or is it just really pattern matching. And so, but in both cases, in the symbolic AI, we haven't had any really big achievements. The 90s is still relevant today. Connections in AI, we are making some advances, but we are also, for every step forward, we are also making some choices that open up vulnerabilities. And so there are adversarial machine learning network algorithms, and this is all very recent, where we find out just how easy it is to trick for example, a self-driving car camera to misinterpret a stop sign into a 45-mile-per-hour speed limit sign. And this is passive hacking. You don't have to do anything. You only have to modify the environment. You don't have to have any active electronic sensing. And so this is new thinking. And so connectionist AI is still really a relatively new field, but yet we have somehow, and there's a whole nother, if you want to join me at another panel, we can talk about magical thinking. And why is it that everyone wants to believe so badly that there's some kind of magic behind the power of AI? And I also don't think that I'm disagreeing with Paul. I agree that there's a lot of progress being made. First of all, China's catching up on symbolic AI. So there's a lot of progress being made there that they didn't make when we were making it in the 90s. So they're making advances there, but they're also trying to leap ahead with connectionist AI. And it should make everyone feel better that my Chinese students are just as bad as my American students. It's just as bad as my European students. They're all awful. And then, by the way, they become employees at all the big AI-based companies around the world. They are incompetent in understanding how to question assumptions. And indeed, this is why we get systems like autopilot, because test and evaluation and double checking and triple checking, these are just not important, sexy parameters that people want to provide funding for. It doesn't look good if your system fails a test. And so AI is making huge advances. That's because everyone's ignoring the testing, operational testing, and evaluation of AI systems.
Paul, so you've written a lot about an area that that Missy mentioned, and there's a question in the chat about, which is human-machine teaming. I mean, whatever, you've both written about this, but I'm turning to Paul next. What are, keeping in mind some of the, limitations that, that Missy's mentioned, what are areas that you view as promising for, why don't we say harnessing machine learning, maybe in the, I don't know, let's give it like a 5 to 10 year time frame to, in the next 5 to 10 years, if you're going to talk about applications of machine learning on the battlefield that they're close-ish to the battlefield, that were helping soldiers, that were, examples of teaming maybe in some ways. What seems most plausible to you?
Yeah, I mean, I think first of all, it's worth pointing out that probably some of the most consequential, applications of machine learning in particular for the military might be in back-end operations, largely just because that's most of what the military does on a day-to-day basis. Now, obviously, the warfighting part is what makes the military unique, but most people in the military are not fighter pilots or Army Rangers. Most people are logisticians. They're managing personnel. They're managing finance. Most of what the military does is moving people and things from point A to point B. On a day-to-day basis, it looks a lot like what Walmart does. It's just what happens at the end that's different. So I do think that, things to optimize operations, improve predictive maintenance, which is one of the things that DoD's talked about, things that help DoD process documents better, might be the kind of things that help streamline operations and be valuable, and might net have huge improvements in efficiencies for military operations and reduce costs. When you look at battlefield operations, I think one of the things that the DoD's turned to immediately, for very clear reasons, is using AI image classifiers to help sift through the mountains of imagery that they have. While when we talk about drones, this sort of, people's public attention goes to drone strikes. The reality is that most of what drones are doing is not kinetic operations. They're not dropping bombs. It's not what makes them valuable. We have existing aircraft that do that just fine. What drones are valuable for is overhead surveillance, continuous, persistent surveillance. The problem with that is then someone's got to watch these video feeds. And for, well over a decade now, the military has had way more video collected from drones than they can possibly process. And that's why one of the first applications DoD settled on for machine learning with Project Maven was to use image classifiers as ways to sift through these images. Now, I think as Missy pointed out, it's not reliable enough that you want to, trust it in the sense of then blindly making some kind of targeting decision based on that information, either a positive or negative decision about attacking a target. It's just not that reliable. Particularly in a realistic environment, we're not operating against, a curated, data set used, say, for evaluating machine learning systems. You take it out in the real world, you're going to see performance degradation. You're going to see stuff in the video footage that wasn't in your training data set that you're not ready for. Maven saw those things in operation and then had to then continue to update their systems. But that is a very, meaningful application. DoD has used it in a whole variety of things in humanitarian assistance for things like surveying floodwaters after flooding to then determine what roads are passable based on satellite imagery and then do automated route mapping for first responders. So it's one of the kinds of things that you can do with AI using image classification. They've worked with California firefighters on tracking wildfires and speeding up the process of getting information to firefighters on the ground about where the wildfires are in real time using machine learning. So that's some of the things that are potentially, could be advantageous using ML today.
What do you think, Missy? I mean, do you agree with Paul about, where we're likely to see AI maybe applied on the battlefield? I want to circle back then in a minute to, how likely that is.
Well, it's not, I can't just give you one swipe and say all these things apply across all technologies. It's been well established for many years that there's a big advantage to using some artificial intelligence analytic approaches in supply and logistics, not just for the military, but really kind of everywhere. And so those kind of deep analysis where you're taking your time and you can look at, question the assumptions, you can figure out where your vulnerabilities are. So I would totally agree, at least in the logistics arena, there is still, I think, a lot of open area for AI to do a lot of good. The image classification, this is just very, very problematic. We do need, the bulk of drone imagery is not able to be analyzed because we don't have enough people or time to look at all the images. And so we do need some help. Unfortunately, we're just now really starting to recognize how brittle a lot of the neural nets are that try to flag various elements of images. And indeed, that's one of the things we're working on in my lab, is to try to figure out, how can you potentially find out where these weaknesses are before you put too many resources into this and end up coming back with kind of garbage in, garbage out approach. And so I think that there is room for AI to grow. And indeed, I still think we're at the ground floor. I think that there's a lot of room that we can make these technologies better. But if we don't sit back and as a group kind of come to an agreement about what does it mean to be better, how can we test these technologies to be better? And indeed, this is part of the problem, is the government doesn't really have anybody on staff that can help them understand what better means. And the Department of Defense doesn't have anyone, the defense industry, they have very few people. Almost all of my students, and when I say this, it's not just me, it's other professors who work in computer science, electrical and computer engineering, anything in autonomous systems, they go to Silicon Valley. It's like the sirens on the shore, bringing everyone to Silicon Valley. People who are the really top people in AI particularly in machine and deep learning, they don't want anything to do with the military. And so I think that's got another issue that we have to resolve. And there's a whole education component of this, is how can we make sure that the military and the defense industry is getting the same kind of talent that is going to Silicon Valley?
Paul, what's your sense of that? I mean, not to disagree with Missy, which is a foolish endeavor, but my sense is that the issue that sort of she pointed out has been getting better over the last couple of years, although perhaps not, sort of based on her comments. How worried are you? And let me make it in an American context. And although I'd be curious, maybe if you could talk a little bit about how you think China's handling this as well. What the relationship between the sort of technology sector and the government looks like.
I think there was this moment of fear, of intense fear, maybe in paranoia from the national security community after Google, decided not to continue its work in Project Maven, where there was a lot of concern that you'd see, Silicon Valley, to sort of use the label, basically AI firms, tech firms say they don't want to work with the Defense Department. I think we've seen that actually largely hasn't come to fruition. Now, it's true that these developments in AI and machine learning are largely coming out of the commercial sector. And of course, DoD has played an important role over decades in funding basic research in AI, and they continue to do so. But it's not your traditional defense contractors that are developing these technologies, right? It's Amazon and Microsoft and Facebook and Google, and that's where it's coming from. That's a challenge for the Defense Department. Those are not companies that you think of as traditional defense contractors. Now, I think what we've seen, though, is that a lot of these companies are willing to work with DoD, right? So on JEDI, you've got Microsoft, Amazon, Oracle, and Google all, very interested in the contract and competing in it. You've got other new startups, Endural, Spark Cognition, Shield AI, say, hey, we want to stand up, we want to work with the government. I don't think that lockout really has come to fruition. And in fact, what you're seeing is probably a minority of tech employees who are very vocal on social issues, sort of raising concerns, writing letters about working with the government, but the corporate leadership in many of these companies saying we want to work with the government. There are barriers, but I think the barriers are largely self-imposed by the Defense Department. They're red tape that the DoD has created, or in some cases that are broader institutional concerns, like we've seen with the protests over the JEDI contract, that make it harder for DoD to work with, not traditional defense companies. DoD has, to their credit, done a lot of organizational innovation with not just Defense Innovation Unit, their outpost out in Silicon Valley, but also other organizations like AFWorks and SoftWorks and other types of ways to try to reach out to startups. I think DoD's biggest problem is the ability to scale that right now. They've had trouble actually bringing that to scale for a whole variety of reasons. But I think that we see that there are engineers that want to work with the DoD, and there are companies that want to do so. Most of the problems are self-imposed by the department.
Okay, I want to argue back with you on this point. Okay, I'm sorry to cut over you, Mike, but let me just tell you right now, 2 weeks ago, I was on another panel, and there was a member of Google, and the whole point of this panel was to talk about where this country, from a defense perspective, should be going with test and evaluation. So the Google person's perspective is that the United States government should spend a very large sum of money to help build digital twins. And Google, for this sum of money, this incredibly large sum of money, is more than happy to build digital twins for the government. So yes, Amazon, Google, other companies are definitely willing, they're motivated by profit to get in there and start pitching away. But indeed, in this one area, and we ended up getting into a little squabble I see a theme here, I'm picking fights on panels, but look, the DoD it might need a little bit of digital twinning, but for a lot of reasons, some of these systems cannot have awesome digital twins. And the reason that autonomy is so hard to develop a digital twin for is that if it's autonomy that has a computer vision aspect, you simply cannot simulate the aspects of the real world that you would need to be able to find out whether or not these systems were effective. So while digital twinning is a little important, in the end, real world operational test and evaluation is desperately what this country needs, both in the military and in the civilian world. And nobody wants to spend that money because it is expensive, it's hard to do, and it takes real people to do. So yes, I do think that compared to 2 years ago, there are more companies that want to work, more traditional Silicon Valley companies that want to work with the Department of Defense. But I'm going to die on this hill, Paul, that the government does not have the right people in place to recognize when they are being sold either a bad bill of goods or, look, it's Amazon and Google's, that's their job to sell a product, right? So they're not doing anything wrong. They're doing their jobs. It is the government's job to know when maybe that technology that somebody's pushing on them doesn't actually match the requirements and the needs of the US government.
Paul, would you like to retort?
No, I think that's a great point. And I think actually this issue of the lack of engineering expertise that's necessary in government for effective program and contract oversight has been cited in a number of areas. In traditional, defense procurement areas, like in shipbuilding or in, fighter jets or something else. It's not unique to AI. It's maybe exacerbated in some of these areas like machine learning. But this is a problem across the board. And certainly you don't have to narrow yourself to AI to find areas of program management and contracting failure and cost overruns for DoD. It's endemic to the system.
All right, so let me switch gears now. We've got a question in the chat from one of our graduate associates who wants to know about something all of us have spent some time thinking about, and I'm sure it's your favorite question in a public forum on AI and military issues, which is about autonomous weapon systems. And this person did not, to be fair to this graduate associate, they did not ask it like this. They said, essentially, if you have some sort of algorithm helping a soldier on the battlefield make a decision about whether to fire a weapon, to what extent is what kind of responsibility does the algorithm have from a moral or ethical perspective, and how should we think about that as a matter of policy when making decisions about the use of force?
Missy, do you want to jump in? You want me to take this?
Why don't you start? I'll let you start before I dive in.
Yeah. All right. Okay. So, I mean, look, the algorithm has none. I mean, that's not simple, right? The algorithm's a tool. And in fact, the Defense Department has been super clear about this in public, in writing. It's in the DoD Law of War Manual, where they have a section on autonomous weapons. That autonomous weapons are merely tools in the hands of people. They have no more legal responsibility than a machine gun does. And that the laws of war, it's a human obligation to comply with the laws of war to ensure legal compliance and compliance with other, ethical principles and rules of engagement. So now you might have an algorithm that's taking certain actions, but as a matter of legal and moral responsibility, the algorithm doesn't take that on.
Missy?
I agree. I agree. There's when people say this, there's a network of people responsible. They're the people that commission the work, the people that do the work, that people do the test and evaluation, which is no one, since we're not really even doing that. They're the people who approve it. They're the people who see it being used in the field. I have seen other warfighters refuse to use experimental technology in the field because they felt like that it was too risky and the system could get beyond their control in a way that made them feel uncomfortable. And so, legally, if something had happened, they would have probably not been held responsible. But even these warfighters recognize that, look, I'm that last line of defense and I'm going to use it in a responsible way. So I think that Paul is right. I think that it redirects the conversation away from where we should to argue about, oh, should an algorithm have moral accountability? I think the question we need to answer in a very specific way is, in the development and testing of these technologies, how much responsibility lies on the original contractor who designs the technology, and how much responsibility lies on the government for accepting flawed technology?
So how do we address that issue? I mean, you've both raised in different ways, and this this kind of circles back in a way. What's the solve to the question of how we have more sort of trained professionals in who understand machine learning and are competent at making those kinds of decisions to ensure that uses of AI are by militaries are appropriate?
I personally think
besides just having you run it, which, to be clear, I would be fine. I would be fine with. I would be totally fine with.
I have not made it. I have not been secret about the fact that I personally believe that I should be head of the United States Research and Engineering Enterprise, but nobody else thinks that.
You have one vote. You have one vote.
Yeah, first of all, I think that we have to understand that we've got to start engaging in better recruitment tools. There are some issues, we don't have time to go into here, about the pay scales and the responsibilities and how we do this. But there are some mechanisms. It's called the STs, the science technologists who are inside the government. We need to kind of blow out those programs, because I actually do believe that people would love to take time off from companies, come into the government, but they don't want to take a 75% pay cut to have to come into this job. And so either it's talking about some shared, funding mechanism. How can we actually do that and still get some of this top talent in? So that's only one small piece. Another big piece is the government needs to get serious about making bigger investments in the kinds of fellowship programs. The DoD has this program called the SMARTS program. And under the SMARTS program, you get your PhD paid for, and you have to do a small payback period of time to work for the government. We need to greatly expand those programs. We need to make computer science free at all community colleges in America. We need so much computer science literacy. It's not even just for the DoD, right? We need to figure out a way to dramatically expand the footprint and make it achievable for a lot of people to go in and get technology degrees. Not everybody needs to have a PhD. In a lot of areas, we just need good IT and good principles in our people, good technical principles to help them as they go into their careers.
Paul?
I guess I'd say there's the specific issue of ways to improve S&T expertise in government, which I think Missy covered. But then there's, your question to me, Mike, strikes this broader issue about human-machine teaming and how do we do this effectively across the military and in a way that's going to allow us to actually employ these systems in a way that's safe and that's effective and they're not, doing something weird on the battlefield or having accidents. I think ultimately it comes down to experience. There are important things about, from a process standpoint, test and evaluation. I do think that we, need to not just reinvigorate, but even probably really beef up our test and evaluation enterprise for machine learning systems, so that they're effective again, for the types of systems that we're seeing people build today in deep learning. But a lot of it's going to come from building up experience with the technology, so that not just on the engineering side, but also on the warfighting side, people get a real kind of seat of the pants, if you will, feel for how these systems are used and what they're capable of. I will point out that we do this today. We do human machine teaming today with physical systems. You cannot fight under sea or in the air without a physical system, or really at the sea surface for very long, except for water polo. You're going to need a physical system to do that. And when we build up the ability to, we build up experience with this. And in fact, the people operating the systems have a lot of intuition about their abilities. We have this in our daily lives. We have intuition about physical systems. When I get in my car, and if I see that the gas light is on, I know I got to put gas in the car. I don't need to be, mechanical engineer to understand that. right? I know if the check engine light goes on, I'm like, oh, I can maybe delay that a couple days, maybe a week, take it into the shop, see what's going on, right? We build up intuitions about these systems by interacting with them. One of the things that's challenging about machine learning systems is they're different and they interact with different cognitive processes. We have different intuitions that might even maybe have to be different than what we're used to dealing with existing computer networks, and in ways that we have some intuitions for those. I think that's going to take time. I do think we'll build it up. But the big thing is building up experience through testing and evaluation, and then using these systems, at least in training environments, so that we can make sure that even the warfighters have some understanding about where they're going to work well and what are the conditions under which they're going to fail.
So I want to circle back to something. We've had a couple questions in the chat asking about, essentially the intersection of many worst case things that could happen, and that being about AI and nuclear weapons. And Paul, you mentioned, I think in your opening remarks, that you were maybe relatively less worried about this in some types of ways. But are there things we need to be concerned about in thinking about the way that militaries might maybe use things like image recognition algorithms to inserting those into how they make choices about like really dangerous things? Like, I mean, war is inherently dangerous, I guess, but like really big explosion things like the use of nuclear weapons.
I think given the destructive potential of nuclear weapons, or maybe more broadly, we could say even war among nuclear powers, it's worth asking the question, certainly, and looking at ways in which we might see autonomy, machine learning affecting nuclear operations, affecting information that's feeding into nuclear operations, or even countermeasures or things that might undermine nuclear stability by, say, for example, making a nuclear deterrent more vulnerable in that sense, or things that might undermine stability even at a conventional level between, say, nuclear armed states. I think there are risks here, but I think they are less about countries directly putting, say, deep learning into their nuclear command and control, which seems very unlikely. And they're more about more peripheral type things, particularly probably on the intelligence analysis front. That could you imagine, faulty systems feeding people bad intel? There's still humans in the loop. There's still humans making decisions. But we've seen, during the Cold War and in the years since, multiple false alarms among nuclear armed countries, where decision makers get bad information, and then the sort of way, unfortunately, that the nuclear risk is set up is oftentimes people under these very time pressure dimensions to make these decisions. I think it's deeply troubling. Some of it depends, I think, your answer a little bit on how you think about nuclear risk overall. If you're sort of like, well, we haven't had a nuclear war so far, so like, we're probably fine, then maybe you're not that worried about it. If your inclination is that we don't really have that much data, we probably can't make a lot of predictions about our confidence of not seeing another nuclear conflict in the future, and we've really never faced the situation of a nuclear false alarm during a period of crisis, then you might be a little more worried about the risk. I think in general, my observation is that I think nuclear risk is probably understated in the US defense community. I think it's not the case maybe in the arms control community, with people that have different perspectives. But when I talk to people in the US defense community, I think people actually probably understate some of the stability risks.
Missy?
If artificial intelligence finds its way into our nuclear program, I quit, right? Like it's just that, I am making a very serious recommendation here. I agree with Paul about all of these points of vulnerability. I think just regular cybersecurity is a huge issue that we need to think about in our, not just the nuclear systems, but across all of the DoD, i.e. solar winds, that was a big disaster. So I think that this company should establish like a commission on AI and nuclear weapons or something like that. And every single contractor that thinks that they're having anything even close to AI get inside these systems, that should go under a very significant and detailed technical review. The risks are just so great that something can go wrong. And I even worry about every now and then you'll see various leaders, civilian leaders, military leaders inside the administration, although this is the previous administration that I'm talking about now. I mean, they make these flippant comments about, oh yeah, missile defense, AI, we've got it all. You know, I worry about that because yes, these are just words, but if you're going to be flippant about those kinds of words and you don't really even understanding what you don't understand what you're saying, you don't understand what the limitations are, then my question is, what else are you not understanding? What other review processes are you not doing for you to understand just what a bad idea that would be at this point in time?
All right, we've got about eight minutes left, and I want to move in some ways beyond the military arena a little bit. We've got a question in the chat that asks, how do you both feel about the influence of AI on social issues beyond military applications, thinking specifically about the influence of algorithms in social media in creating echo chambers that foster extremism, essentially like the Facebook, kind of Facebook, Twitter, issue, and the way that algorithms may exacerbate extremism. Obviously this is outside the military dimension, specifically, but is this something that either of you have been thinking about? Is this something that you're, is this something that you're worried about? And to what extent is this about the algorithms versus about like our tiny brains and our, inability to make good judgments?
Well, I can comment directly on that. If you want to think of a metaphor for AI, it's a mirror. Just hold the mirror up. That's what AI does, especially connectionist AI. It models, it represents what we know, maybe not what we know, it's actually what we think we know and what we think we see in the world. And so AI, you can use all the learning that you want, but if the core of the underlying data set that you're trying to learn something about has some kind of inherent bias baked into it, whether or not that's race or some kind of cultural phenomenon or whatever, the AI is reflective. That is all AI deep learning is. It's a reflection tool. And if you get something wrong in the image that's being reflected back, then that is going to come out in the machine learning algorithm. I do not think that deep learning can tell you anything introspective. Deep learning can only show you what you, the person who designed that algorithm, and I just recently published another article just about, your interpretation of a machine learning algorithm is going to be the answer. There is no quantitative. Machine learning is not a quantitative, objective mathematical approach. It is a very subjective, reflective analytic technique. And so garbage in, garbage out.
Yeah, I mean, I would make a clear distinction here between how we're seeing AI integrated in democratic societies and authoritarian ones. And in some cases, it's the same technology, facial recognition cameras, for example. But the social context, the governance structure in which it's used is very, very different. So what do I mean by that? Well, we have a lot of debates in the United States, in other democratic countries in Europe and elsewhere about a lot of these AI technologies, whether it's facial recognition, whether it's algorithms and social media and how they're used to promote and elevate certain kinds of content. Is that, making people more, pushing people towards more extreme content? I think these are important debates to have. I see the fact that we are having these debates as a sign of a healthy and functioning tech governance ecosystem. I certainly am not in a position where technology shouldn't be governed. That's silly, right? The only reason why we have clean air and water and safe food to eat and safe airplanes to get on and safe highways is because we have regulation here in the United States that governs all of these kinds of technologies. Digital technologies, aren't special that they are immune from regulation. But I think the fact that we have like a give and take about these debates, the fact that you have groups of civil society raising concerns about these technologies, you have an independent media that's sort of highlighting abuses, is the sign of a functioning process that is likely to more or less get it right. Not perfect, but avoid extremely bad kind of outcomes on either side. None of that exists in authoritarian regimes. So when I think about tech governance, I think to myself, what, we'll probably figure it out here in America. They'll probably figure it out in Europe. But when I look at, what's going on in China, the way that they're deploying massive surveillance systems, the way that they're using, facial recognition to suppress minorities, to monitor the population, I'm deeply, deeply concerned about the employment of this technology in authoritarian regimes, and then these models of tech governance coming out of authoritarian states and being spread to other countries around the globe. And I think that's deeply troubling when we think about sort of the balance between freedom and authoritarianism globally.
So let me wrap up with a question about say an application of AI in a way that is, that's hit the news a lot over the last couple of years, or at least news that all of us read, and that's GPT-3, a neural based language processing system, created by OpenAI, and you see kind of, this is the like AI can write your news articles, like kind of thing. And you see, I would say, wildly varying perspectives in commentary on this about the extent to which this is a big deal and like a national security threat versus like, this is like a computer that is frankly not that bright and there's not much to worry about. So, and many of the questions that we've talked about, I actually, probably whatever. We all know each other. Like, I kind of know what you would say. I actually don't know what either of you will answer to this question. So I'm very excited to hear GPT-3, like big deal or nah, like national security threat or nah.
Where's that eye roll emoji? I need a big eye roll emoji. Like, not only is it not a big deal, but it only proves everything that I've ever been saying anything. Like, remember, OpenAI actually is not as open as you would think that they might be, given their name. They're there to make
for-profit company AI.
Yeah, right. That's right. So they're trying to make money. Large language models, they've got something to sell you. They don't work. They don't work for all the other reasons that we talk about contextualizing and differences in environments and backgrounds. And, we've been playing at these word writing, articles for a long time. It's still an academic game. It's not, I think the best use of these technologies are to write sports articles. If you've seen some of these sports articles, because they're highly formulaic and, you can get away with that. But I am definitely not worried at all. My job is secure of putting, stringing together abstract thought and being able to come up with new concepts. No, we are not there at all. You just need to remember GPT-3 is a tool that someone's trying to sell.
Paul, take us home.
I'm happy to give a little bit of, just add on a note of disagreement here. I think like GPT-3 is a great topic because it is a polarizing one, and it's one where people seem to have these very, very different reactions to. I would say from an AI standpoint, I think it's impressive. I think it's impressive for a couple of reasons. One is the text is, at least within a chunk of a paragraph, basically indistinguishable from human-generated text. It's good enough. Now, over the course of like several pages of text, it like largely doesn't seem to make sense on a higher level. It's not like if you generated a 5-paragraph essay and turned it in, for an English class, you'd probably get a big F because it doesn't make any sense, right? But within a given paragraph, like it's been proven in experiments with humans humans think it's generated by people, right? So it's effective synthetic text. I think from a standpoint of like AI methods, I know there's a lot of haters about deep learning. I'll just point out, I don't have a stake in this. I don't work in this field, but it works better than any other method. And I think one of the things that's interesting as well, and OpenAI is probably one of the bigger adherents of this sort of like throw a bunch of data and compute at a problem and then like see what happens. There are others too. Google Brain just released a trillion parameter language model. DeepMind, of course, has done similar kinds of methods. And a lot of people don't like this because it's not it's not the method that a lot of AI researchers have used for decades, building hand-tailored bespoke systems. I can understand if you spent your career in symbolic AI, it's very disappointing, but it works better than anything else that people have done. And it's really, really impressive. Having said that, there's a ton of limitations today, right? It's certainly not, the system itself doesn't understand what it's producing, and there's clearly no intentionality behind it, right? So it is merely designed to predict the next word in a string of text. It can produce plausible text if you read it. It doesn't have a purpose the way that, like, if a person is writing, you have some purpose to persuade or explain something or self-expression or something else. And none of that exists. From a national security threat standpoint, like, yeah, I think in general, synthetic media has real risks. Text and audio are probably much more viable today from a technical standpoint than video, which is still lagging behind. But one of the things it does is allow just the generation of spam faster and can cause risk, or fake news faster and at scale. I don't think it's going to lead to like some kind of information apocalypse, but I think these are real challenges. Like when OpenAI didn't release GPT-2 originally, they were accused of, a lot of overhyping things. I think we do need to be in a place now where we have differentiated release for some AI products. I think that's realistic. We see that in the cybersecurity world. And now that we're getting to a place where AI technology is good enough to be done, used in the real world, I think it's fair to say that there might be certain things that you don't want to just give to everyone. And there might be some ways in which there could be, malicious applications of the technology.
All right. Well, unfortunately, we are out of time, but thank you both for what has been, at least for me, one of the most fun and entertaining events that we've done this year. We're grateful for both of your time. So, thank you all very much. And thanks to our audience for joining us for this edition of The World Today, Worst Case Scenarios. And we hope to see you again next week for our next World Today event on February 16th. With Professor Susan Lindy from the University of Pennsylvania, who'll be talking about her new book, Science, Technology, and Modern War, The Rational Fog. We've got a real kind of a war-heavy couple weeks coming up. Since on February 23rd, our next edition of Worst Case Scenarios will focus on thermonuclear war, featuring Rachel Bronson from the Bulletin of the Atomic Scientist and former U.S. Secretary of Defense William Perry. You can follow Perry Worldhouse on social media at Perry Worldhouse. On Twitter, Instagram, et cetera. And join me again in thanking Paul and Missy for an unbelievable educational and entertaining program today. Thanks very much, everybody.